Today we're going to learn about radian and degree measure. Before we do that, let's define a few things. These are probably things that you've seen back in geometry. Firstly, trigonometry. Trigonometry is the study of angles and side lengths of various triangles. Now, what we're going to be doing is primarily working with angles. So what is an angle? It's a measure by rotating a ray from an initial position to an ending or terminal position. So we've got one here. It looks like it started out with a vertex going off to the right, and then we just rotated this a little bit counterclockwise, and we ended at a terminal side. So this created an angle, and the part that goes between these two sides is what we measure for that angle. Well, an angle with its initial side on the positive x-axis is considered in standard position. And that's primarily what we're going to be doing. All of our initial sides for today are going to start on the positive x-axis, and we're rotating it either clockwise or clockwise, depending on what we're doing. If we rotate it counterclockwise, then it's a positive angle. If we rotate it counterclockwise, then it's a negative angle. And if two angles happen to have the same initial and terminal sides, then they're considered coterminal. So here I've got one that starts and then ends at the same spot. Alpha and beta, these are both coterminal. Same thing here. We've got an angle that went up a little bit, and then the second angle went all the way around the circle and then up that same little bit. These are considered coterminal. So then what is this radian measure? Well, it's one way to measure these angles that's particularly useful in calculus. To define a radian, we're going to use a central angle of a circle whose vertex is the center of this circle. And what we're going to do is have this radius be 1. Well, we know that the circumference of this circle, 2 pi r, but if r is 1, then it's just 2 pi, goes all the way around the circle. Well, in radians, all the way around the circle is this 2 pi, which means that we can actually split this up into the different sections or the different quadrants. Let's take a look here. I'm starting at 0, and if I go all the way around, I end up back at 2 pi. Well, that means that pi is halfway across, otherwise known as 180 degrees if we're more familiar with degrees. And half of that would be pi over 2, or half a pi. This is 90 degrees. Well, halfway between pi and 2 pi would be 1.5 pi, or 3 over 2 pi, 3 pi over 2. That means that everything in quadrant 1 in radians is between 0 and pi over 2. Everything in quadrant 2 is between pi over 2 and pi. Everything in quadrant 3 is from pi to 3 pi over 2. Quadrant 4, 3 pi over 2 to pi. Now note here, because of coterminal angles and the fact that we're making a circle and we can go around this circle a whole bunch of times, then there are infinitely many coterminal angles for each of these angles, whether we measure them in radians or degrees. Essentially, any angle, if you add or subtract 2 pi, meaning add or subtract a full rotation around a circle, you will get back to the same exact position. So let's do some examples. Say I've got 13 pi over 6, and I want to find something that is coterminal. Well, let's start with writing down 13 pi over 6. I know that I can either add or subtract 2 pi to this to find something that is coterminal. So what I'm going to do is I'm going to subtract 2 pi, except because this is a fraction, the denominator 6, I'm not just going to subtract 2 pi, I'm going to say 2 pi is the same as 12 pi over 6, because 12 divided by 6 is. So let's subtract 12 pi over 6. Well, 13 minus 12 is 1, so this is just 1 pi over 6, or just pi over 6. That means that these two, 13 pi over 6 and pi over 6, are essentially the same angle. They're coterminal. What about this one, 3 pi over? Let's write that one down. Again, I can add or subtract 2 pi to find something that's coterminal to this. 2 pi in this case, because of a denominator of 4, is going to be 8 pi over 4. Let's add 8 pi over 4 to both this here. When I add 8 pi over 4 to 3 pi over 4, I will get 11 pi over 4. So 3 pi over 4 is coterminal to 11 pi over 4. Negative 2 pi over 3. Usually with these negative ones, I like to add 2 pi, so that way I hopefully end up with something positive. Let's write down negative 2 pi over 3. And I'm going to add 2 pi in this case because the denominator is 3, add 6 pi. Negative 2 pi plus 6 pi, so that's going to be 4 pi over 3. And lastly, got 16 pi over 5. This time let's subtract. So let's start with 16 pi over 5. Because the denominator is 5, 2 pi is going to be the same as 10 pi over 5. So let's subtract 10 pi over 5 from both sides. And this is going to be equal to, let's see, 16 minus 10 is 6. So 6 pi over 5. This is coterminal to 16 pi over 5. Now, you may be more familiar with degrees at this point. Most people are. So a second and more familiar measure for angles is degrees. As we now understand that a full rotation around a circle in radians is 2 pi, and that same full rotation around a circle in degrees is 360 degrees, we can convert from one measure to the other by using this 2 pi equals 360 degrees, or if we reduce this, pi equals 80 degrees. Since these are the same, then to convert from degrees to radians, I can multiply by pi over 180 degrees. And to convert from radians to degrees, I can multiply by 180 degrees over pi. So in these examples, I'm going to use that. Let's go down the left side first. I want to convert all of these radian measures to degrees. Let's start by writing down what we've got. Got pi over 6 for this one, pi over 4, and pi over 3. Now for each of these, if I'm starting with radians, I'm going to multiply by 180 degrees over pi. So for each of these, I'm writing down times 180 degrees over pi, like so. Well, what's going to end up happening is I've got a pi on top and a pi on the bottom. These are going to divide each other out. And what I'm left with is 180 degrees over 6. On my calculator, I can just put in 180 divided by 6. This is 30 degrees. For this one, I've got 180 degrees over 4, so 180 divided by 4. This is 45 degrees. And lastly, 180 degrees divided by 3. This is 60 degrees. All right, on the right side, I'm starting with degrees. So 90 degrees, 135 degrees, and 540 degrees. For each of these, let's flip this upside down. I'm going to multiply by pi over 180 degrees. Okay, here's how you do this. In your calculator, you're essentially going to have 90 pi over 180. So you can take 90, divide by 180, and you get 0.5 pi. Now we know 0.5 is the same as 1/2. Let's say that we didn't know. Say we got some weird decimal and we wanted to convert this to a fraction. Here's how you do this in the TI-84 plus CE. You're going to hit math. The first option here is fraction, so you're going to hit enter and then just hit enter again. So we see this is 1/2. So this is 1/2 pi, or 1 pi, just pi, over 2. For this next one, I've got 135 over 180. So in my calculator, 135 divided by 180. This is 0.75 pi. We know this as 3/4, but let's say that we didn't. Math, enter, enter. And this gives me 4. So this is 3 pi over 4. All right, lastly, 540 over 180. That's just a clean 3. So this is a 3 pi. Two more things I want to do. One, let's talk about arc length. Then 2, let's use arc length in some kind of problem. So the arc length of a circle, which is a section of the circumference, can be found by using the formula S equals R theta. Now remember, the circumference of a circle is pi r. Okay? So circumference equals 2 pi r. Say 2 pi r. So 2 pi r, but if r is 1, then this is 2 pi as my central angle. Well, here, instead of doing r times 2 pi or 2 pi r, I'm just going to do a part of that circumference. So let's say instead of a full 360 degrees, in this problem, I've only got 240 degrees. I want to find the outside of this circle for just that 240 degrees. But I've got a note here. Central angle must be radians. So for this particular problem, I've got a circle with radius 4, and the central angle is 240 degrees. The first thing I need to do is convert this 240 degrees to radians. Luckily, do this. So we're going to start with 240 degrees. And we are going to multiply, since we're looking for radians, by pi over 180 degrees. So on my calculator, I'm going to do 240 divided by 180. This gives me 1.3 repeating. As a fraction, math, enter, enter. This is the same as 4 over. So this is 4 pi over 3. Now I can go ahead and use arc length. S for the arc length equals r times theta. Theta here is my central angle, 4 pi over 3. So S equals r times theta. For us, that's going to be 4 for the radius times my central angle is 4 pi over 3. So I've got S equals 4 times 4 is 16. This is 16 pi over 3. And it didn't give me what units this is in, whether inches, centimeters, etc. Let's say that it wanted me to find something that's in inches or centimeters that's rounded. Well, then I would take 16 second here to get pi, and then do divided by 3. This would be close to 16.755, whatever your units are. Lastly, what can we do with this arc length? Well, one thing is we can find the linear speed. Linear speed is how fast an object is moving around the edge of a circle. Oftentimes, this could be used in perhaps astronomy, thinking about something orbiting a planet or some kind of planetary object. Here, we're just going to use a clock. The linear speed is equal to the arc length divided by the time it takes to move along that arc length. As an example, let's say we've got this clock here. The second hand is 10.2 centimeters long. I want to find the linear speed of the very tip of the second hand. So let's see. The arc length is a part of the circumference, or sometimes, I guess, we could say for a clock, let's find the entire circumference, because we know that the second hand is going to go the entire way around this clock. So arc length is going to be the same as the circumference, 2 pi r. Well, r is 10.2 centimeters, so this is going to be 2 pi times 10.2, which is going to be 20.4 pi centimeters. Now next, we know that it takes 60 seconds for this second hand to go all the way around the clock. So 60 seconds to go all the way around. Or in other words, it takes 60 seconds to travel 20.4 pi centimeters. Well, now I've got the arc length and I've got the time. The linear speed is equal to the arc length s over the time t. For us, that's going to be 20.4 pi centimeters over time is 60 seconds. In the calculator, 20.4 pi there we go, 20.4 pi divided by 60 is 1.068. So my linear speed, or in other words, how fast the tip of this second hand is traveling, is 1.068 centimeters per second. All right, so now we've learned a little bit about radians, paired them to degrees, which was something that was a little more familiar, as well as finding out something about arc lengths and how to use them to calculate linear speed.